Hi gents, we're going to do the graphical version now of resultant forces of the force systems. We've done the mathematical already. There we go. Our answer for a resultant was 9.16 newtons over degrees of 79 degrees. So that's what we're aiming for. Now remember I said you can do graphical, mathematical first. It doesn't really matter. So right now, and then we're doing the exercise 1-1 again. So we have two forces, 10 newtons, 8 newtons, both are 30 degrees. So let's have a little go. First step, and we always write in our first step, is that's our scale. So we always need to set our scale for our marker so he understands or she understands what our scale is. So we have two figures and they're quite small, so 10 newtons, 8 newtons. So we're thinking maybe a scale of 10 millimeters equals 1 newton. Now if they were large, okay, or 500 newtons, you might choose a scale of 1 millimeters is to 10 newtons, or 1 millimeters is to 5 newtons. Okay, so that way, at the end of the day, you want your drawing to be of a good size, so it's easy and clear for your marker to read. So what did we say? We said 10 millimeters equals 1 newton. So we know straight away that that's going to be 80 millimeters and that's going to be 100 millimeters. Yeah, so we at least know that straight off. So let's have a little go. First step we want to do, you want to draw a nice straight line along the bottom. Yeah, I start as close to the bottom as possible. Okay, we draw that in. And we want to, and it doesn't matter which force you start with here. You could start with the 10 or the 8. I'm going to start with the 8. So it's 8 newtons, so 80 millimeters, 30 degrees. So grab your protractor. I'm going to start around the middle. Okay, flip that the right way. Start around the middle here. Okay. Place a little mark for your center. That's important, so at least you know where to start. Okay. So we said 30 degrees. Place a mark for your 30 degrees. There we go. Now we have two marks. Slide your page a little bit. Grab your rule. Now this first line, it doesn't matter how far we go. We know we need to go at least 80 millimeters. So just line up those two marks and draw that nice straight line along. Okay, there we go. Okay, so we have that. Now, from here, we can write in a few little things. So we know in this corner we're 30 degrees. Okay. We know that our arrow going out here needs to be on the end of that 80. So let's have a go. Let's measure this and place our 80 mark. There we go. So there we go. That's where we know we need to stop, that 80 millimeters. So let's have a look at our next force now. It's 10 newtons with 30 degrees again. So 100 millimeters we said. So now this makes it difficult because basically we need to come 30 degrees off there with our protractor, but that is going to allow us to move too much. So we know straight away, okay, off here, if we had our 90 degrees in here, this angle in here would be 60 degrees, wouldn't it be? So we can use that 60 degrees now. So we place our protractor on that line, right on that point. Right on that point there we go. Place in 60 degrees. Okay, there we go. And we want to join those two up. Now we know that one's got to be 10 millimeters, so we need 100 millimeters. Sorry, we need to move this at least further than that. So draw that nice and long. There we go. There we go. We'll draw in just a rough dotted line. So that's the center. Okay. We'll put a 30 degrees in this corner because that's important. We brought that in. We can put an arrow on this head here to say that that was where the 8 newtons was going, and we were doing that. Okay, so there we go. We're starting to label a little bit. Now, next step, 100 millimeters. There we go. Place it right on that dot. 100 millimeters. There we go. Put a dot there. So that's where we're going to stop. We know that's the 10 newton line. Now the next bit's quite easy because we can put this arrow straight in now because that's where we need to stop. Yeah. And all you're doing with your rule is you're just going from where you started from. So you place that dot right on the end of that arrowhead where you started, draw your straight line in. There we go. Okay. Place the other arrowhead at the top, because remember we're doing resultant. So resultant tells us that two arrows should clash. Okay. If it was equilibrium, you'd have your arrows going in some sort of motion. So then we can put this as our resultant in here. We're going to find that out in a second. So now all we need to use is do our protractor to measure our angle. And we know it should be around 79 degrees. So let's have a little measure. We'll place it right there on the dot. Have a look at that. That measures dead on 80 degrees. So we're not too far. We're only 1 degree out. That's quite good. So put in there 80 degrees. Okay. And then we measure this. Now remember, graphical, you're not going to get the exact answer, but you want it pretty close. So 1 degree out is quite good. Now that one there is 92 millimeters. So we know straight away, okay, that's 9.2 newtons. Okay. And if we have a look up here, 9.16 newtons. So we were very, very close for that one. So that was quite good. Now, gents, that's it. That's the graphical version of how to find your resultant. And like I said before, scale is very important that you place that in straight away, and then you can have a look and go graphically. Thank you.